Hello, class. This is Mr. Weckesser. This is 1.3 Algebraic Expressions. If you remember, in 1.1, we discussed expressions before, and these are usually numerical and algebraic. We'll talk about those in a second. Here we go. Vocabulary. Simplify. Remember, you're not solving, you're just simplifying. You're adding like terms. Sometimes there is an answer, sometimes there's not a definitive answer. You have some variables and things like that left over each numerical expression. So there's no variable in this. So here, the key thing for this right here is you need to know how to distribute. We talked about that at the end of chapter 1.2. 6, 5 minus 2 plus 7. You need to know something and how to do order of operations for this. So we're going to scroll up to the top and say, oh, what do we need to do this? This is something called PEMDAS. And hopefully you remember this from middle school and maybe Algebra 1 a little bit. These are the order of operations. Please excuse my dear Aunt Sally. We have parentheses first, exponents next. Exponent looks like this. Remember, a little square there. Multiplication. We also have division. We have addition. And we have subtraction. And that's the order. There's also a new kind of order. They kind of do it now with this P, E. They have an M and the D come at the same time, and the A and the S come at the same time. The good thing is if you have a bunch of numbers, you put them in your calculator. If you have a right calculator that we use, this won't really matter. But you need to know parentheses always comes first, exponents next when you're doing things maybe without a calculator. So this is for expressions. Right here we have 6 parentheses 5 minus 2 parentheses plus 7. So we're supposed to do is inside the parentheses first. 5 minus 2 is 3 plus 7. What is 6 times 3 now? Because 6 times 3 or the parentheses should come next, or multiplication comes before the addition. 6 times 3 is 18. 18 plus 7 is 25. Again, you could probably do this on your calculator and get an answer. In the real world, which we're trying to get you ready for, you can use a calculator. So I'm okay with using a calculator for everything. Number two is one that's difficult to use a calculator for because there's a huge division sign under all these numbers. So you want to do what's on top first. When you have a huge division like this, you can imagine there's parentheses around everything on top and do what's up there first. Or if it's all on the bottom, do what's all on the bottom first and then divide. So number two, 7 plus 5. As you can see from the order of operations, addition comes way, way after multiplication. So we're going to do multiplication first. 5 dot, which means multiplication, times negative 3. So 5 times negative 3 is negative 15 divided by 4. Again, imagine when there's an operation on top of the division sign or the fraction that there's a parentheses. You need to do what's on top of the division first. So 7 plus a negative 15 equals negative 8. In Algebra 2, another good thing about expressions is whenever there's a fraction, all fractions mean to divide. 8 divided by 4 is 2, and it's a negative, so it's a negative 2. And there's your answer. That's how we found it. So fraction. First thing about fractions you need to know about in Algebra 2 is they are good. You're allowed to keep fractions. You're also allowed to keep improper fraction, like this, 23 over 8. If you see that, you don't need to simplify it. You don't need to turn it into a mixed number. Just keep it. But fractions always mean to divide. It's another cheat for Algebra 2. A fraction just means division. Number 3. So we have 2 exponents here. You're going to do those separately, right? So the square root of negative 5 squared is going to be 25. And then you have negative 4 squared. 4 times 4 is 16. So 25 minus 16 does equal 9. So you're going to do those first. The exponents, here's your PEMDAS, before you do your multiplication and division. and before you do your addition, and in this case, there was subtraction right there. So remember PEMDAS for Algebra 2. Vocabulary builder. Definition: to evaluate an expression means to substitute a number for each variable and then simplify to get a value. So when it says evaluate before homework, you're just substituting a number in and solving. So for this one, x equals 2 and y equals 3. Substitute 2 in for x and 3 in for y. So 2, the first expression says xy. And then you're going to say 2 times 3, and 2 times 3 equals 6. That's how you evaluate. So that's the key vocab for this lesson. Use your vocabulary. Evaluate the expression for given values of the variables. So here we have a plus b over 4. A equals -2. B equals 8. Right? 8 divided by 4 is 2. We're going to divide before we add. So -2 plus 2 equals 0. And you can see how they got 0 and we got 0. Number 5, you have x minus x squared times y. X is going to be 3, we know, and y is going to be -4. So 3 minus 3 squared times -4. If we use order of operations, we know that PEMDAS is parentheses. There's nothing you can do inside the parentheses here. Exponents is here next. So -3 squared is 9. So we have 3 minus 9 times -4. Put this in your calculator, you're going to get the answer 39, but we can do without a calculator. We know multiplication comes first. -9 times -4 is a positive 36. 3 plus 36 is a positive 39. Okay, the key concepts of 1-3. Lots and lots of properties. Again, you do not need to memorize these. Do not memorize. Do not memorize. But you need to know what they do and what they are. For instance, distributive property of subtraction. Here we go. A times B minus C. So A times B is first, and A times -C is minus AC. Multiplication property of 0. Anything times 0 is 0. We learned that in like first grade. Multiplication property of -1. Anything times -1 is that negative number or letter. Opposite of a sum. So here's the opposite. If you have a negative outside of parentheses, you distribute that negative into the parentheses. So both or anything inside the parentheses becomes negatives. Opposite of a difference. Remember, difference means subtraction. So opposite of a subtraction is addition. So negative A, then a negative times a negative is actually a positive B. You can put that in your calculator like this. Negative, put parentheses, 2 minus 1, right? And it'll show you how to do that. The opposite of an opposite, and this is again the same thing. A negative times a negative equals a positive. Again, you learned that a long time ago. Got it. Problem 1, modeling words with algebraic expression. Which algebraic expression models the word phrase 2 times the sum of A and B? So let's think about that. 2 times the sum. 2 times, we always use parentheses. The sum is addition of A and B. That's how I would write that right away when I saw it. The word times means you should multiply. The word sum means addition. So now write the expression 2 times A plus B, or you can write it like this, the same as I did up here. When I see these written out like this, I always just write down what I see and see if it makes sense. So down here, there's more of these. 10, 11, 12, 13, 14, and 15. The difference of 7 and 4, and this is probably one of the most difficult ones because the difference of 7 and 4 means subtraction. So 7 minus 4. The product of 3 and x, product means multiplication. So 3 times x, or you can write it this way. or just 3x. The number y increased by 2. Increase means plus. The quotient of 48 and 3. Quotient means division. 48 divided by 3. So you'll see that, or a lot of times we'll do this now in Algebra 2. The number t is doubled, then decreased by 1. So whenever you see the word doubled, you need to know it means 2 times it. So 2 times t minus 1. 5 taken away from q. And this is a difficult one because you have to put q first. Q minus 5. Modeling a situation. You had $150, but you are spending $2 each day. So here's 150 bucks. Spending means subtract. That's what I'm gonna write down right away. The word spending means subtract. $2 per day. That's how I'd write the expression right away. Let's see if I got it right. To find the variable, let d equal the number of days, which we did up there. Relate. Starting amount is 150. The amount spent per day is minus 2. Number of days is d. So your answer would be 150 minus 2d. Evaluating algebraic expressions. What is the value of this expression? And now all of a sudden we went from easiness to this. And you're like, what is going on, Mr. Weckeser? And I'm like, yeah, I know. It gets hard quick. So we need to really stop and think, is this that hard? No. If we stop and think and just substituted what was in it. X equals 6. There you go. Y equals negative 3. There you go. So here is our substitution. Let's go to the next page. So after we did that, the 6 became 36 and the 3 became 9. So we have 2 times 36 minus 9, parentheses, divided by 3. 2 times 27 divided by 3, right? A couple ways you can have done that. I don't know how all of a sudden they got to 2 times 9. You're like, how did they do that, Mr. Weckeser? Well, they simplified. 27 divided by 3 is 9 over 1. You could have done 2 times 27, got 54 divided by 3 equals 18. A couple ways you can do that. But remember, when you have a big fraction, you need to put everything on the top in parentheses. So if you did this in your calculator, which you can do, but it's just difficult to do, you put everything in the top in parentheses, hit divide, and everything in the bottom in parentheses too. And you'll get that answer of 18. Problem 4, writing and evaluating expression. In basketball, teams can score by making 2-point shots, 3-point shots, and 1-point free throws. Write an algebraic expression models the total number of points that a basketball team scores in a game. If a team makes 10 2-point shots, right? So here you go. You let t equal number of 2-point shots. And 5 3-pointers. 5 3-pointers are represented by H. And 7 free throws, which is represented by an F. This is how you put in the expression. I mean, your formula is like this: 2t plus 3h plus f. Because 2 points, 3 points, and 1 point, if you know anything about basketball. And we are just copying what we learned down there to up here. You're going to insert those numbers in, and you get 42. There you go. And the expression 5ax plus 6y minus 7 has 3 terms. I don't know what we're not going to. This is kind of we're not going to do this part here. I'm just going to stop that. So coefficients in the constant. Couple key vocab words here. Coefficient is a number next to a letter. So a co means like it's dependent upon. So the 2 is next to an x, and the negative 3 is next to an x. They are coefficients. Constant means never changing. So this never changes. The 5 does not change. No matter what happens, the 5 does not change. Nothing affects the 5. So the coefficients for this 26 are negative 4 and 8. The constant is negative 3. So this is a vocabulary word they're trying to build upon coefficients and constants. The constant's a big one because we'll learn about the constant coming up, and that's how we graph. Problem 5, simplifying an algebraic expression. Combine like terms. What is simpler form of this expression? Here's a long expression, right? At the right is one student's solution, and it looks like they're going to say it's wrong. There's a big X through it. What error did Rosie make? So let's look at her errors. It's kind of tough because they put an X through it. But she has 4j squared minus 7k plus 5j plus j squared. So this is the exact same as the original one. And then she did 3j squared, negative 3j squared. So she combined this and this. Combining those together, you do get negative 3j squared. That is correct. So far she's good. Then she had negative 7k, which is good, and a 5j. So this is also correct. Now, she combines the 7k and the 5j. This is where the big mistake happens right here. She cannot combine a k and a j. So remember, you cannot do this right here. If this is right here written down in the problem, you cannot combine those. And I'm pretty sure that's what 27 says. Explanations may vary. Sample, the terms negative 7k and 5j have different variables, so they cannot be combined. Simplify the expression correctly. So we're going to do it correctly, and we kind of did it up here. You just have to put down here everything from this right here. 3j squared minus 7k plus 5j. They actually did it wrong here. It should be a negative 3j squared, I believe. So lesson check. Do you understand? And this, again, this is supposed to be on your own. I'll give you the answer. You might want to pause, come back to it. But these are numerical expressions down here in algebraic expressions. Numerical one has no letters. Algebraic ones have letters. Algebraic A, numerical all letter numbers. Algebraic because it has variables. And then math success down here. Check out the vocabulary words that you understand. Term, evaluate, coefficient member is attached to something. Constant is not attached. It's a number by itself, a term, and like terms. And then you're going to rate yourself. How much did I get this unit? Did I understand it? So I'm going to stop this, and I'll see you next chapter.